So if that's not the case, then we move forward to Thomas. Pleased to introduce you. You're, I think, a really typical example of an entrepreneurial scientist. So namely that after you study chemistry, you finished your MBA, but then already also immediately joined Biotech, Iris Biotech, in more than 20 years ago. But then also more recently, you found another company, and I'm very much looking forward to hear your story so far.
Yeah. Thank you, Christiane. And thank you, Beat, for being so persistent to bring me here. It's a pleasure being here. Thank you. All right. So we at Iris Biotech, we understand ourselves as a service provider for the biotech and pharmaceutical industry. And in this context, we have made in the last couple of years a lot of work in the field of linkerology. And in this presentation, I will explain two technologies which I think are a bit quite exotic and interesting, which is on one side the cell-free production of biomolecules, and on the other side plasma treatment of Teflon surfaces, both with the intention to introduce functional groups on these carrier molecules for subsequent linker attachment or linker cargo attachment. So first introduction to this topic in general. Here you see the well-known ADC Adcetris. It has the carrier molecule, which is a CD30 targeting antibody, targeting vehicle, and the carrier for this whole construction. In the middle, then, there is the linker. You see already here in a fragmentized manner here. And on the right side, there is the cargo molecule, which is MMAE, and which carries as point of connectivity a secondary amine function. So if we expand this example now to all further possibilities which you can think of, then you see as carriers, there are, of course, antibodies and proteins possible, but it can further be extended to metals, metal oxides, yeah, even, let's say, any kind of plastic, polymers, polyethylene, polystyrene, and a lot of different carriers. In the center, you see the hundreds, maybe 1,000 different possibilities of linkers which can be designed. And on the right side, you see the cargo molecules symbolized here with the different functional groups which are used for attachment to the linker. So in this field, within the last 5 or so years, lots of linkers, specific linkers only, or linker cargo conjugates, or preparations of carrier molecules. And here I just want to select two different methodologies and explain a little bit more in detail what that is, how it works, and what the benefits are. So let's first come to cell-free production of biologics. So we start here with fermenting the cells, eukaryotic cells, CHO cells or insect cells can be used. Then the cells are being destroyed, cell walls are being removed, and we take only the lysate from that, add plasmid or PCR fragments, certain additional components like amino acids and ATP energy and things like that. And then the ribosome starts its work to produce any kind of biologics what has been programmed. So the point is now that in this specific case, tRNA synthetases loaded with non-canonical amino acids can be added. That means in the yielding biomolecule, unusual or let's say non-canonical amino acids can be introduced at any specific point of this compound. And that gives the initial point for starting the linker attachment and using it for further linkerology. It also has a couple of other advantages. It is very easy and fast to carry out within a day or two, you can receive the compound. It's also scalable, so could be used then in larger productions, and could also very quickly set up a high throughput screening. So what we basically only need is the DNA sequence, and with that, any kind of antibody fragments, nanobodies, fusion antibodies can be produced, including the capabilities of introduction of non-canonical amino acids at very specific points. Besides that, challenging proteins like membrane proteins, toxic proteins can be produced, which are otherwise difficult or unable to yield. So now we make a hard break and come to the second technology, which is plasma treatment. So consider an implant, for example, which goes into the human body, made of Teflon. Then the top layer is just of fluorine and totally not biocompatible. So with the help of plasma, we can remove the top layer atoms and substitute them by functional groups. If you use, for example, ammonia plasma, then amino functions will be introduced on the surface, which can be the anchor point of the next linker or cargo attachment. A further advanced technology is then the use of acrylic acid, and then propionic acid handle is being introduced, which has certain advantages to the use of amine function. So, and here we see how it basically works. So a little movie. So there is a chamber where you can put your sample inside. Then the air is being removed. It's not a super vacuum, just a normal oil pump to a certain low level. And after that, the chamber is filled with the gas of choice. Hydrogen is, for example, used for just etching or cleaning the surface, or we can use ammonia or acrylic acid. Then current is applied and the plasma starts being performed. And now they let the sample in this chamber for some 5 or 30 minutes, and then basically the reaction is being done. So no technology is worth anything if you can't control it. The surface control or quality control progress of the synthesis has been done with X-ray photoelectron spectroscopy. You see on the right side that each individual atom has a very well separated signal. And for example, in the case of carbon, you even can enlarge and deconvolute the signal and identify individual oxidation levels of the carbon. So through this technology, you get a nice information about the progress or success of this treatment, and you get a kind of molecular formula just on the surface. So with this, I want to conclude and summarize. So I showed you two different quite extreme technologies, how to prepare cargos for conjugation, linker attachment. The one is cell-free synthesis of biologics with the specific advantage to introduce non-canonical amino acids, for example, like para-acetophenylalanine, which then can be used for conjugation, for example, with the clicker compound from Christiane. And the second possibility was surface treatment of polymer surfaces with introduction of certain functional groups, which also then can be used for linker attachment. So we specialized in this linkerology field already since a couple of years and have put together all our experiences and examples in a kind of brochure, which you can download from our website and go through that. So with this, I want to close, and then let's move on to Lonza.
Thank you, Thomas, for a very nice overview of indeed two different areas, but two really exciting areas as well.